Alright, so I'm trying to print this shelf on my K1 here and kept running into issues. It would, first layer would peel up. And so, I don't know if it was because it was silk PLA or what, but covering the full bed, it kept peeling up. So then what I did, I decided to slow the first layer down from 50 millimeters a second default to 30 or 20, and that seemed to do it. And so then it completed, after a few tries, then it completed the first few layers, and unfortunately the filament got tangled around the filament spool holder pegged there in the back somehow. I don't know how that happened, and stopped it from extruding. It wasn't like a tangle like I let the end go, and it got tucked underneath, as usually as happens sometimes to people. This was, I had successfully printed earlier, never changed the filament, just somehow the filament got tucked under the filament peg. It was weird. But anyway, so I went to reprint it. No, actually, before I went to reprint it, I did notice that on the first layer, I didn't like the way the first layer was anyway. So I went back in, and I can't find Z offset in the new Creality print slicer, so I went back to the old Creality print slicer so I could adjust the Z offset, and I have a video how to do that if you're curious how to do that. And I adjusted the Z offset a bit, and I might have messed with the speed, or maybe it's just because I went back to the old slicer. Some default setting is different, but for whatever reason, now I'm getting under extrusion. It gets part way through the first layer, and the extruder starts clicking, which tells me that the PLA, as it tends to do, gets too soft in the print head and then jams the extruder. And so I had that failure. And so now I've gone back and really tried to do something quite different, and we'll see how this plays out. So what I did is I turned the bed temperature way up, and I'll say that backwards. I turned the nozzle temperature down from 230 to 200 on the initial layer, and to compensate for that, and also to help hopefully get the first layer to print smoother, I put the bed temperature up from, 40 by default to 75, which is technically too hot for PLA by the recommendations, but I figure, and I also have the fans cranking, because I'm just trying to keep the print head cool enough so that the PLA doesn't jam. So we'll see how this plays out. Now I think I'm still at 20 millimeters a second on the print speed, although it looks like it's kind of hauling ass here. I don't know, you tell me, is that 20? I mean, that looks faster. Maybe I accidentally went faster? But anyway, the point here is can I get away with turning the temperature way down on the nozzle to not soften the filament, and then compensate for that, and also compensate for the rough first layer by upping the bed temperature to higher than recommended for the material. Will those things add up to? Oh, and I also, like I say, I also changed the Z offset from, I believe, from minus 0.05, which is default. I think I went to minus 0.02. Might have been minus 0.03, but I think I did minus 0.02. So hopefully the extruder doesn't start clicking. So it would usually make it like halfway through the first layer, as you can see on this one. That's when it started. That gap is where it was basically under extruding. So let's see how this plays out. So far so good. It's a little bit ripply in this corner, but could be normal. So our print temperature is 74 degrees. What? Oh man. And the nozzle temperature is 230. I swear I put it at 200, and that reminds me of a bug in the old version. I forgot about that. There was always a bug that would give you the wrong nozzle temperature. I totally forgot about that. I hadn't used the slicer in a while. So that's unfortunate. So I expect, well, if I'm lucky, that's weird. There's a gap between the brim and the first line. That's not very helpful to the brim. Okay, well, not ideal. But what I did do though, otherwise, is crank the. Ooh, I wonder if I can turn the nozzle temperature down manually. Ah, I can. 200. Go. Nice. All right. I manually set. You can see here. I manually set the nozzle temperature down to 200 from the 230 it was wrongfully at, and so we'll see. Oh, well, that's interesting. That gap seems to have gone away on this side, but not on that side or that side. Huh? Okay, I see. It's that's weird. It didn't print the outside line first. Outside after the brim, I mean. So that brim is like 5mm, I believe I put. Interesting to see how much more space I have around the brim. This brim was basically taking up the entire bed on the front and rear, other than maybe 1mm on the screen. And I can see I have like another centimeter here, and same over there except for the screws. Obviously I don't want to crash into the screws, but that's good to know. Could even, I wonder if I could make a custom printer profile and increase the bed size of that little extra bit that is actually on the print surface. Now that I say that out loud though, I realize that it's quite possible that the heater doesn't extend, the bed heater doesn't necessarily extend the full width of the print bed. But that's kind of a misnomer anyway. That's not the right word. That's to misname something. But I think. But anyway, it's inaccurate because any heater isn't heating uniformly. It's basically a wire that snakes through the heater, and it's only heating at the wire. And then, you know, the finer you space the wire, then the more uniform the heating would be theoretically. You know, if you look at any kind of heater, whether it be an electric blanket or a toaster, or you can even see it on your nozzle in the ceramic on if you have a K1. It's just a circuit of wire that it's a wire, but it's a higher resistance. It's like intentionally higher resistance than a copper wire. So copper has very low electrical resistance, and so doesn't tend to heat up too much if you run current through it. But if you run too much current through it, it will get hot. Like your copper wires will get hot. Now, interestingly, silver is a much higher, a much lower resistance to to electrical conductivity. So, if wires were made out of silver, then they would be much lower resistance, and they would make less heat. But I believe silver is significantly heavier than copper, and it's also significantly more expensive than copper. I believe in aerospace wire they do silver plate the copper strands, if I recall correctly from my aerospace days. And it's like grade, what do they call it? Like 55? What do they call that? Class 55, grade 55. It was something 55 if I recall correctly. I could be way off, and you can mock me in the comments, and you could do that either way. But I believe it was some kind of Spec 55. Is that what it was? Spec 55 wire? It was kind of the aerospace wire. I don't know. I could be making it all up. Anyway, so when we were designing high temperature solenoids, electromagnetic coils, we considered, among other things, silver wire. I don't know why we never did that, because you could definitely get a more dense magnet if you use silver wire, but there could be plenty of reasons to not. There's always a bunch of trade studies. You know, you trade off, you know, what do you gain, what does it cost you to go to various materials or processes or designs or features or styles or however you want to look at things. All right, so far so good here. You know what's funny is I was looking back at some of my old videos, and some of my more popular videos were actually me just standing here talking about printing while watching the print, and I noticed that I said, yeah, I don't do that anymore. And all I was out here trying to do is take a couple shorts to show what was going on with this, and I kept running out of short time, and so then I decided that I will, instead of doing a short on this one, that I would just take a couple minute video while I talk, and now I'm over 10 minutes that I haven't shut up. So welcome to my friend's world. Let's see, what else do we have going on here? I noticed on this, I really like this print bed and the pattern that it makes on the bottom of the print, which is one of the reasons I'm reprinting this shelf. I already have this shelf, or a very similar version, actually added more hooks. It's got hooks underneath it to hang things from. I already have a very similar one in my bathroom, but I like the way the pattern appears on the bottom surface of the prints, and this shelf prints upside down, which makes sense because the top of the shelf is flat. So I figured it would be cool to make this shelf with this pattern on the top surface of the shelf, which is the bottom surface of the print. I did just notice one thing today, though, in looking at some test samples, and I don't know if I have it right here. I might have thrown it away, but I noticed that the surface isn't super flat. Meaning, I guess I can look on this big one, but there was a small sample test coupon that I had printed that demonstrated that to me. There was like a little, it started to click. No, okay, I don't think it was the extruder. So my nozzle temperature is down to 200. The bed temperature is at 75, which is very hot for PLA. And so far so good, but we're still early in this layer. So we'll see how that plays out. And you can see on this one, for example, this was this first layer, I was getting that wrinkling, and that's pretty typical. I did a deep dive video series last year, about a year ago, on trying to get the perfect single layer print on the K1, and I realized I learned something in doing that. Is in that with the Z offset at minus 0.05 millimeters, which is the default setting. And I say that, I hope I did minus 0.02 and not minus 0.2. No, that would crash the bed. Wait a minute. I'm confusing myself now. Okay, yeah, so minus would be closer to the bed. So minus 0.02 is further from the bed than minus 0.05. But yeah, so if I did minus 0.2, I would be crashing the bed. So, hopefully I didn't do that. I don't think I did it because I don't see the bed crashing. But anyway, back to the, meanwhile, back at the ranch, this wrinkling I was thinking was undesirable. And so I went to like a minus 0.00 on the Z offset. And that looked much better on the top of the bottom, than the top surface of the first layer. But when I peeled it off, the layer lines weren't, sorry, not the layer lines, the lines were not bonded to each other well. So if you're actually printing more than one layer, that imperfection of the first layer I found to be actually desirable, because once it laid down the second layer, it would squash the first layer flat, and I found it to be very effective. But now on this one, I think the difference is because silk PLA. I'm printing a lot more with silk PLA lately, and I'm noticing significant differences from regular PLA to silk PLA in its mechanical properties. And specifically, what I mean by that is there's like almost no stringing in between, like spider webbing. You know what I mean? So, for example, if you saw my Starship pen model, the launch tower, the Mechazilla, those sort of truss lines, like it prints flat, and it makes like a truss shape, and then you put it all together. And the idea with that was that it would eliminate the spider webbing, because all I had to do was draw the straight lines flat on the bed. But then I realized when I tried to use Hyper PLA that it was traveling outside those lines, so it would traverse over the gaps, and I would still get the spider webbing, which is super annoying. If anybody knows how to eliminate that, short of creating your own slicer, which I actually read a good book about, you can actually create your own slicer, whether it be oversimplified or as far as you wanted to take it. using Rhino, and more importantly Grasshopper, which is a plugin within Rhino, and it used to be a plugin, now it's just included. Grasshopper, if you don't know what Grasshopper is and you do CAD, man, you want to see Grasshopper. Like, I remember the first time I saw an image of a complex model created by Grasshopper. I didn't know what it was, and I just saw this CAD model and I was like, there is no way I could do that in SolidWorks, like no way. And so I looked it up and it was Grasshopper, and then I did a Google image search for Rhino Grasshopper, and it's just a, you know, infinite number of awesome models that you just can't seem to do with other softwares that I know of. It just gives you so much freedom of complexity in the way, because it's like algorithmic, and there are other advantages to it too. Like, instead of just a chronological feature tree like in SolidWorks, it's actually a canvas, like a flow chart, and you can plug things in and disconnect things, and you can swap things in, and you have a ton of freedom, and you can like scale things non-uniformly. Like, if you have a pattern, you can pick and choose which ones scale by how much. You can randomize things. Like the world is your oyster. You just have so much flexibility. It's not as intuitive as like a SolidWorks, which is funny to say because SolidWorks isn't extremely intuitive until you're used to it. But Grasshopper is much more sort of programming level, and you can really like literally program it. You can program SolidWorks too. Don't get me wrong. You can do scripts and things in SolidWorks, and I've done that a little bit. I'm not much of a scripter, but I have gone into AI and told it to write me scripts for SolidWorks and have had it do things like write macros for me and things like that. And you can have it make commands for you if you're sophisticated enough. And this print looking good so far, so good, and looking very flat too. This might be an excellent strategy, but we'll see. We'll see how it plays out. But anyway, so where was I going with that? Oh, so I read this great book. I don't remember what it's called. Maybe I'll put it in the comments if I remember to. But it was basically making your own slicer to print with ceramic. So this guy was 3D printing ceramic, and is ceramic the right word? I believe so. 3D printing with ceramic, and he was making his own slicer within Grasshopper and Rhino, and it was really not very complicated. You're just programming a G-code generator, and so I say that now I could theoretically make my own slicer to print, because I've noticed that before, that I print something flat and so that it won't spider web, and then it's all over the place. Like, its path is not just sort of doing vase mode. I mean, I guess I could do vase mode. I didn't think of trying vase mode on those pieces. That might do it. Maybe I'll have to try that. Maybe I'll have to try vase mode on those. Maybe that's a lot easier than making my own actual slicer within Grasshopper. But it's an option. And maybe I'll do that. And I think I actually followed along. Now that I think about it, I think I actually followed, and it's not even a long book either. Maybe 100 pages or so. With a lot of pictures, in fact. But I believe I did follow along with the book and created my own very basic slicer. I'll have to look at that and see if I must have. Like, it wouldn't have made sense for me not to. So I'll have to go back and look at that. But realistically, I don't care that much. And so where I was going, how I got to there, as I say, meanwhile back at the ranch, I find that silk PLA spiderwebs far less, to the point where I had printed those and the chopstick arms and the QDA, and there was basically no spider webbing at all, even if it wasn't, even like on the chopsticks, they're not even flat to the bed, and there was absolutely no spider webbing. And when I did it in ASA, there was actually a little bit of spider webbing, and I always loved the ASA because it was so resistant to spider webbing. But these silk PLAs, or at least the ones I was using, like it seems to eliminate the spider webbing. It just seems to be so good at shutting off and not oozing. And I also notice, I'm sure it's a related property, that like if you manually extrude, meaning if you disengage the clutch and put it up to temperature and stuff the filament through manually, the filament like expands like crazy coming out of the nozzle. And so I found that really interesting. I imagine it seems to be a very elastic material, meaning that it springs back like crazy. And I think that's what helps it to not spiderweb, really. Hope this noise isn't too bad. I don't have my headset out here. Let's see, what else? This is actually looking really good. I mean, I kind of want to sit here and watch the whole first layer, but we're already at 20 and a half minutes, and I don't know, we're a quarter of the way through, if that. So this could take a while. Let's see, what else can I come up with to talk about? I'm tempted to buy this same print bed for my K1 Max. Oh, that's one thing I was showing. I wanted to try to show here, and I noticed somehow I'm stuck to my sample is stuck to the filament. There it goes. So let me see if I can find a spot where it's kind of like, it's like the print surface is actually sort of bubbled a little bit. I don't know if it's actually bubbled or if it's just not flat, but I saw a couple little dimples on one print little test coupon that I had that I don't have in front of me. And I wonder how much, if at all, those little dimples may have contributed to, not on this one, but like on the failures where it's sort of peeled up. But I don't think so, because on the sample it didn't fail. So where is that little piece? Now I want to find that little piece. I might have actually thrown it away. I'm not sure what I would have done with it. I wasn't throwing it away. I don't know what I did with them. They were just little, you know what? Oh, you know what? I probably brought it in the house. Oh, here's one. Here's the same piece, different test. So maybe. I'm trying to see it through the camera. So now I'm just looking with not through the camera. Alright, on this one I don't see it. On this one it looks like quote unquote perfectly flat. Obviously not perfectly flat, but on another one there were little bumps. Or I should say there were little dents. So like there were little bumps on and not like abrupt, like sort of bubbly, not like a full bubble, but just like a soft dent, like a dimple, like a golf ball dimple, a lot less pronounced. But there were just a couple of little, very minor dimples. I don't see it on this one, no matter how I move it. Actually, that's pretty good. Get the light to reflect off of there. So this one's not a good example. For whatever reason, the other one, the later one, or I say it's later, I think it was a later one, because it was the last one I did of these samples. And that one was a little bit wavy. So the surface of this bed is not perfectly flat, not a big surprise. Nobody's got perfect. There's no such thing as perfection in engineering. So yeah, I'm thinking about buying this print bed for my Max, but I don't care. This one, I actually needed a new print bed for this one, which is why I pulled the trigger. After a year with that print bed, and I printed some 300C polycarbonate more than once, and you can see there's another video you can go back and see where I was printing the pretty large footprint polycarbonate parts, and the polycarbonate warping was stronger than the magnet on the surface of the print bed, and so it curled the print bed right off the magnet like a Pringles potato chip. And so I thought I would be smart and use binder clips, and so I went all the way. I took the part off, let it cool, and I took binder clips and I clipped the entire perimeter of the bed to get it so it would help the magnet stay down. And then I printed it again, and again this is at 300 degrees C, and that's when I realized that the print bed surface is actually glued to the steel, and that the glue softened up at 300 degrees C, and it actually peeled the print surface right off the steel, not the steel off the magnet. It pulled the sticker right off the steel, and I sort of panicked and got the part off and pushed it all back down, and I actually had to peel it up like most of the way off, and then luckily I was able to reapply it while it was still hot, which was funny dealing with that, as it's literally the temperature of boiling water, 100 degrees C. But well, you know, it was obviously cooling a little bit as I went. But I don't know, I might have actually kept the temperature up because I don't want it the glue to harden while it was not properly in place. And so I was able to reapply the sticker, and then I still used it for like another year, and I still have it here. Where is it? It's up here somewhere. It still works. Just it had some bubbles, and I was trying to print something. I don't remember what I was trying to print, but I was trying to print something, and it was annoying me that the first layer was yucky, to use a technical term. And so I decided to buy a new print bed. Now, don't judge me for all this glue on this print bed. This does not need to be there. I think that was my first test print with the new print bed. But so this print bed is a little, you know, it looks like a heat shield from a spacecraft that just did re-entry. It's like you can't really see it because of all the glue. But if I get rid of all this glue, like there's little micro cracks all over it, and there's bubbles under it. You can see some bubbles there, I think, and it was in rough shape. And so I decided to get a new bed, and so then I was looking them up. I saw this one, and I had seen a video some time back where somebody had a similar print bed to this with the color pattern texture, and I thought it was pretty neat, so I figured I'd go with that. Plus, it looks like it's not a sticker, but you know what? It probably is, actually, now that I think about it. But we'll see. I have not tried printing at 300 degrees C, and I'm not going to try to intentionally destroy this print bed because I like it, and they don't give them away. It wasn't super expensive. I think the K1 Max one, I think it was $30. I was looking, but I was like, yeah, I don't need it. My K1 Max bed is in really good shape. Other than the purge line is all scraped up, and I'm debating. Like I was thinking about getting a new one under warranty, but it's just the purge line. It's like, who cares? It's not even on the actual print surface, so it's fine. I'm not sure exactly what happened there. I think it may have actually been my own fault due to, you know, just speculating here. Like if I printed with a higher temperature material and then I went back to like PLA and didn't purge it properly, and then it went to do the purge line and it wasn't hot enough to soften the higher temperature material, which would probably have been like ASA, maybe PET G, but I don't even think I've printed PET G on the K1 Max yet, which is crazy. I just don't print much with PET G. Somebody just asked me in the comments of one of my videos, actually just this morning, what temperatures I was using for PET G, and I said, you know, that print was like a year ago, and like I probably haven't printed, this isn't exactly the answer I gave him, but I haven't printed probably a year. I probably haven't printed PET G in like a year. That video was probably one of the last times I printed PET G. Not that I don't like PET G, but just I have so much PLA, and PLA is so easy to print with, and I have so much of it to go through. And I have a bunch of PET G too, but it's just what I happen to have in the printer. It just happens to be PET G, PLA, and then it's just, you know, it's just easier to just keep going with PLA. And I'm also really liking this silk PLA. Like I've been printing a lot with silk PLAs, and like I say, they seem to print even nicer than ASA, which is saying something. I always like the way ASA prints. But these aren't really structural parts that I'm printing most of the time. I say that, it's a funny thing. So I made these, there's another video up there, I'm sure, of mine. I made some nylon barbell hooks. So I have one of these power racks. It's, you know, like a 4-post weightlifting rack, and it's got a pull-up bar. I really just wanted a pull-up bar. But it also came with this power rack, which you can put safety bars, you can do squats in it, and you can put barbell on it, and you can put your weight bench in it. So I ended up buying one, and it's really cool. But the hooks that you put the barbell on are all like eye level and lower, which sucks because if I want to walk around behind the thing, it's kind of takes up most of the space at one end of my office, and I feed my cat back there, and it's a pain with the barbell in the way to get back to where I feed my cat, and also just to get back to the weights which store on the back. So what I wanted to do is store the barbell overhead so I could walk under it and not worry about hitting my head on it or just it being in my way, being awkward. And so I made them out of nylon, and I I engineered them, like I used my structural analysis software to ensure that they were way overkill strong, because I don't want it to come crashing down. The barbell weighs 45 pounds and the thing's 7 feet off the ground, so I don't want that coming crashing down, whether it lands on somebody or just my floor. And so I way over engineered them and printed them out of nylon, because nylon is very tough plastic for relative to other plastics, elastomers, whatever. Nylon is very strong, very tough material, and so I did that. And then I've been using those for months, and they work great. And then I decided I wanted some on the front. You may have seen that video. And so I made, rather than do a bunch of tests in nylon, which is a lot more expensive, I decided to do testing with PLA, and it's a little different. For the hooks on the front, it's a different hook because it's different interfaces. And so I did it based on the same design, but just had to change the geometry so it would work on the front of the rack. And so I made them out of PLA with like only 2 walls and like 4% infill. I thought they were going to be super weak, and I put them up there, and I just to test it, and I put the barbell up there, and it was holding it fine. I was like, that's weird. And so I kind of put some of my weight on it, and they were like super strong. Like, of course, I didn't try to do a pull-up or anything, but surprisingly, the PLA was plenty strong enough to hold my barbell up there. So I actually still have the PLA version of those hooks up there, and they seem to be doing just fine. And so hopefully nobody dies, including my floor. Alright, speaking of floor, this first layer is looking excellent. Like, I'm getting none of that wrinkling. Now, we could still clog. The big question is, will I jam the extruder? But the temperature is 201 right now at the nozzle, or at the thermistor at least. And so, looking good. Obviously, there's not a thermistor in the cold end of the extruder, so I can't really know. It could still end up clogging, but man, so far so good. And by the way, the bed temperature is super high right now, but after the initial layers, and I didn't notice a setting. I thought there was a setting somewhere that I could say how many initial layers, but I think it was 2, but I'm not sure. So, but after the initial layers, it's going to go back to the default temperature, which was 40 or 45 for the default settings. And the old print slice, Creality print slicer, whatever version that is, not version, what is it, version 3 or version 5? Is that the new one? I don't know. But we're looking good. There's a little streak there. I'm not sure what that little streak is about. Maybe it changed direction. Did it change direction, or did it start to jam? That's weird. I don't know. Or was there debris? You know, there is a little bit of debris. I got lazy and I didn't wipe the bed much. I think I kind of got lazy because the print keeps failing. So I got sick of cleaning the bed. And so now if this one prints properly, I'll be a little bit annoyed that I'll have some imperfections likely on the surface. But it'll give it some character. If I really wanted to be dangerous, I could throw some alcohol on the thing and wipe that right now. And I think I'm actually going to do that now that I think about it. I just happen to have some alcohol right here and coffee filter right here. And I'm going to do it. I'm going to kick myself if I wreck this somehow by doing this. But I'm going to try to do it. Oh, that's stubborn. Yeah, it's hot too. I didn't quite get all of it. Another bit here. I get it dislodged. I know, I'm living dangerously here. But if this print completes, I'll be happy that I did. Oh, there's another piece here. There, I got it. Got that one. Got that one. Did I see some over here? I'm gonna call that good enough. I'm not gonna play with fire there. That. See? Oh, I got a little dot there still though. I'm getting. It could be getting a little too risky. One last little dot. Alright, got it. And I probably just moved the dots around. So I'll probably still have the imperfections. But so far so good. Looking a little streaky over there too. Not sure what the deal is. Not sure what the deal is with that streak. That must have been like debris. I bet you that was a little piece of debris on the bed with the nozzle like pushed a little bit. I'm just guessing. Man, that looks super clean. Oh, look at that. Like I say, this is, I believe, is a minus 0.02 millimeter Z offset on this that I did specifically to avoid the wrinkling it got, because I'd rather have little voids between the lines of the top layer, of the bottom layer, which is the top of the shelf. I'd rather have little void lines than wrinkles. Those wrinkles look horrible. Where did that go? This guy. Like these wrinkles, like I don't want those on my shelf. Like I want my shelf to look like that, right? Not like that. So, we'll see what happens. Man, this is taking all year here. We are 35 and a half minutes in, and we're not even halfway done with this. What else can I talk about? I don't know. Well, at least we know it only takes me 35 minutes, 36 minutes to run out of things to talk about. So, let's see. What else about my... Oh, so yeah, I also ordered upgrade kit, but I'm for the nozzle on this. And so if you... I see I gained many subscriber on that video. So it's a short video. Showing that I wanted to upgrade my nozzle on the K1 here, and because I saw like the cold swap nozzles. So basically, they integrate the regular, instead of the nozzle being separate from the heat break, which is also advantageous to this printer because as you can see, I got a blob in the back. You see it? Yeah, I got a blob on the back, which to me that's obvious that it's likely a slight gap between my nozzle and heat break. And so it's oozing out a little bit over time, and it's making that blob. And so this should also solve that. But basically, it's one continuous part. Instead of being a nozzle separate from the heat break, it's the entire thing. The entire nozzle comes up through the cold end. And the nozzle is the hot end and the cold end with the heat break in between, and comes right out the top, I think, here. And so I believe like the K1 Max and the K1C and whatever other ones come with that already, but that was technology that came out after or at least from Creality, after the K1 was released, and so my K1 doesn't have that. It's much more conventional. And so I ordered. So I was looking at the Creality sells a 0.4 millimeter version of that, and it's also like a high flow nozzle also. But I said, I'd rather have a 0.6 millimeter nozzle of that. And so I looked around, couldn't find the Creality one, or at least not on Amazon. I realized later I should check Creality's website. But I saw a no-name brand version that was 0.6 millimeter, and it's also, I don't know, nickel plated or hardened or something, so I can use abrasive materials. And I also ordered the hardened gears, so I can do abrasive materials on this printer while I'm in there. But then I realized after, I'm not sure if that nozzle is the high flow nozzle or if it's just 0.6 millimeter, which would kind of suck if I upgraded to a non-high flow nozzle. But I can always add the high flow version. But the funny thing is, so the no-name brand version was like $13 or something, and the Creality version was like $65 or something. So even if it doesn't end up getting me a bunch of high flow, at least I'm going to hardened material and a 0.6 millimeter nozzle. So I'm gonna have to before I swap that, I'm gonna have to do a test to see somehow to, and I'm sure there's a test there for testing the flow rate of your nozzles. I see people, calculating flow rates and testing flow rates and things, and I've never done it, but I'm sure it's not rocket science because it doesn't have to go into orbit. So why would you need rocket science? But anyway, the great thing about being in the information age, it's easy to look stuff up and see how other people did it. And so I'm going to likely, before I swap that in to here, and it actually, by the way, it arrived yesterday, and so it's on my kitchen table and just waiting to be installed. So any month now, I'll get to that, I'm sure. And so I'll do some before and after testing to see the flow. And then after I do all that, I'm just thinking maybe I will order, if I don't get crazy awesome flow out of that 0.6 millimeter, maybe I will actually order the expensive Creality 0.4 millimeter quick cold swap nozzle and compare that to the 6 millimeter and see if I'm actually not just as fast with the 0.4 millimeter as the 0.6 millimeter if the 0.4 is high flow technology and the 0.6 millimeter is not. And basically what I mean by high flow is that what they do is they split the path of the, so on a conventional nozzle it's just a straight hole straight through the nozzle, and so you get, you know, the heating and melting of the filament is a function of the surface area of the filament touching the metal, right? And so what they do is they basically split it to multiple paths. So instead of a 1.75 millimeter filament coming through, and that's not really the, how do I say it? So the actual nozzle orifice, let's say it's 0.4 millimeter, that's just at the tip. As you go up a little bit, it gets much wider, the hole gets much wider, and that increases your surface area, as I mentioned, so it allows heat transfer, thermal transfer to the filament from the heated nozzle to melt the filament better. But what they do on the high flow ones is they actually split the path to multiple paths that the filament is melting through, and that in turn also increases the surface area of the filament, you know, of the plastic contacting the metal, and allows it to melt faster. And there's a lot of different ways to do it. Somebody did a deep dive on it. Might have been Maker's Muse, might have been CNC Kitchen, one of those guys. Might have been Tom Sandlatter. I don't think so, though. I think it might have been Maker's Muse. I don't know. One of these guys did a deep dive and actually made their own version of a high flow nozzle, basically by just drilling a hole sideways through it and then putting like a piece of wire across, like a piece of coat hanger, metal coat hanger or something across, and that actually still achieved it, basically because it split the flow. And I'm thinking about that. I'm not sure exactly how that would work, because you'd have to, it seems like you would have to widen the channel to not decrease the cross-section area. But anyway, it was many months ago that I watched that, so I don't remember exactly, but that's basically how they work, and there's a bunch of different ways to do it. But so I don't know if this cheap nozzle that I ordered is actually high flow. I need to go back and look at the ad again, or even just look at the physical. Well, I can't see inside it, I don't think, but maybe it's on the packaging, maybe it says it. And something came in a Creality box. So, oh no, that's right. Actually, so that nozzle might not have come in yet, because what actually came in was which was the parts that are from Creality, which is so after I ordered the nozzle and I posted the video, as you can see, it's one of my most recent shorts, and somebody did reply in the comments, regretfully I don't have his name in front of me, somebody replied that that it won't actually fit without the upgrade kit. So there's something about the print head in the K1 that I have to update in order for it to accept that nozzle. So I followed up and ordered that. So now that I think about it, those are the parts that came in. And I think that actually came with, I imagine it came with that style nozzle also, but maybe not. But probably not the $65 one, especially because I don't think it was that expensive. So I'm sure it's not the really good nozzle. Man, this is going to take all month to finish this one layer. But it is what it is. We're almost halfway there, and so far so good. And this guy, well, actually, now that I look, this one that I happen to have here that failed, well, this didn't fail by curling up. This failed by under extruding. But all right, well, we basically made it to where we started under extruding, and I don't hear any clicks yet. So far so good. We're doing at least as well as before, and the layer is much smoother than this one was. So my strategy of overheating the bed while underheating the nozzle seems to be working so far. And I suspect that, you know, the underheating the nozzle is not what's helping me be flatter, just to be clear. That's sort of two different goals for two different setting changes. The turning down the heat on the nozzle was to not get heat creep in the hot end, in the cold end, to soften the filament to cause a jam. Whereas the temperature increase, significant temperature increase on the bed, was simply to let the filament sort of land smoother on the bed by just being a lot hotter on the bed. as opposed to the 45 degrees, which just didn't cause. And like I say, I think it's because of that high elastic characteristic of the silk filament. I suspect that if I just did regular PLA, that wrinkling would not be an issue, or at least it would be less of an issue. But due to it being silk, that it's just so elastic, meaning it returns to its close to its original shape, or it tends to, that was causing my wrinkling there. So, well, we're at 45 minutes, and amazingly, and my friends wouldn't be surprised, I still haven't run out of things to talk about. Let's see, what else? I have a ton of filament. I think I counted how many spools of filament I had a few months ago, and I want to say it was like around 100, either full or partially, not empty spools, and I've thrown away plenty of spools too that I used up. But I definitely have tons of filament, lots of PLA, lots of silk PLA, lots of PET G, lots of various. I have black ASA, I have white. Actually, I ran out of black ASA, and I didn't bother to reorder it because I don't have a use case for it yet. But I'll probably be ordering some black ASA as soon as I come up with something else that I want to be black. No, let me restate that. I ran out of black ASA, and I printed parts in gray ASA, those handlebar horns. You may have seen that video or not. I mean, tens and tens of people saw it. But, so I made those gray because I ran out of black. And so I wanted to reprint those in black, I believe, so I reordered black. And then I almost ordered some white along with it, but I said I don't have a use case for the white, so I may follow up and order some white ASA. Maybe not. May not bother. So I have those. I have probably 3 or 4 different spools of TPU. I have some polypropylene that I just came across the other day, which was interesting. That's really interesting stuff to print. The polypropylene, which is what they make like gas cans out of and stuff like that. It's interesting the way it prints. It's challenging though because it won't stick to anything, and basically you have to put packing tape, like shipping tape, upside down, sticky side up on your print bed. So that's a little tricky in itself to get that stuck to your print bed, because that adhesive on the shipping tape is the only thing pretty much that the polypropylene will stick to. Like, you can forget about printing with it unless you do that. And the annoying thing about that is your print comes out and it's sticky on the bottom. Oh, no, I said that backwards. I take that back. You have to stick the tape to the print bed because the tape's not sticking. I'm sorry, the print is not sticking to the adhesive. The print will only stick to the non-sticky side of the tape. That's what it is. So you stick the tape to the print bed and then you print on that. But the annoying part about that is when your print is done, your bottom surface of your print is sticky like packing tape. And you'd think you could just peel it off. No, you can't. It's just there. It's just there. And eventually, I guess it'll get dirty or oily or whatever, and then it'll be less sticky. But it's sticky for a while. Like, I made a little, I don't know if you've seen my little minimalist wallet that I'm sure I've printed on a video somewhere. I've printed a bunch of versions of it. I printed out of TPU, printed it out of ASA, printed it out of PLA, printed it out of polypropylene. Polypropylene one was really neat. It's very, like, a lot more flexible than the other materials other than the TPU, but a different flexibility than the TPU. Is really interesting. But it was annoying because it always had that sticky bottom surface on it. But I still liked it anyway, and I still used it for a long time anyway. And I used it basically until I have this green, really soft TPU, and I decided one day, just randomly, the filament was in the printer, and so I decided to print myself a wallet out of that color because I've done a bunch of different ones. And I don't have my wallet. I mean, I would show it to you. I don't have it on me. But I like the green one a little better. Well, actually, no. Well, yeah, and I used the green one for a while, but now I'm using, I don't know if it's ASA or if it's carbon-filled nylon. It might be carbon-filled nylon. It was some dark colored filament that I was already printing with, and I just randomly decided to print a wallet out of it, and I've been using that one ever since. But I did like the TPU one. I might go back to the TPU one. It's in my house somewhere. Actually, I think it's in my truck, just holding spare cash. If anybody ever needs spare cash, It's in my console. In a little wallet. I'll try to leave the doors unlocked so you don't have to smash my windows. Thank you very much. Let's see. What else is going on? Oh, I also have some polycarbonate material, which annoyingly fell off the shelf and broke the spool and got all tangled up. So, but that's such a pain to print with that stuff anyway that I don't care too much. Like small parts, it's fine. If you look at my video, and as I explained earlier, it basically tried to destroy my print bed because it warps so much, and that's in the chamber of a K1, so it really likes to warp. I think so. I had some success with polycarbonate that I had. So my first printer was a Aleph Objects Lulzbot Taz 6 was my first 3D printer. Way overpriced, way under-reliable printer, but it was American. It was made in the USA, so I had that going for it, and it had optional print heads, and that's really the reason I went to it. I wanted to do dual material. And this was back in 2018, and I really wanted dual material so I could print with the dissolvable. What is that? PVA, polyvinyl acid. I think it's PVA. I think it's the same stuff the glue stick's made out of, I believe. And I don't know if it says it on here what it's made out of. All-purpose glue stick. Probably doesn't say the ingredients. Washable, safe, non-toxic. Made in China. Not toxic unless you inhale as solid, because then you choke on it. And I think that's also. I think it's all PVA. But the problem with that PVA dissolvable, and I was just talking to a client about this recently because I sent them some complex parts, prototype parts for him to print on his end, and he said he was buying a new printer with dual material, and I mentioned to him that the problem with that is they don't tell you everything about that when they sell that to you, is that that stuff dissolves so slow. I found it to be super annoying. It took so long for it to dissolve, and then I would get my print out of it, and it would be all sticky. Like most of it would be gone, but it'd be super sticky, which was kind of grossly annoying. And look how good this is doing. It's really coming out well. And so that was bad enough as it is. But then the other thing is they say you can't pour it down your drain. Not because it's toxic, but because it clogs the hell out of everything. And so if I have a vat of this stuff, like I've seen people like, oh, I have a fish tank full of this water to dissolve this, glue filament with the dissolvable support material, but that water comes out so freaking slimy, and then at some point you got to get rid of the, what do you get, a 10-gallon fish tank? Now you got 10 gallons of slime water you got to dispose of. What are you gonna do? Just throw it on the ground? I don't know. Do you filter it? Do you try to filter it? It's just going to clog it. If you try to put it through a coffee filter, it's just going to clog it. I may have actually tried that. I'm not sure. But basically, I figured that's a scam. But I do have some other PVA filament around here somewhere. But it's actually 3mm filament. So the Lulzbot printer, at least the Taz 6, uses 3mm filament, whereas most others use a 1.75mm. But they did have a high flow extruder head. They called it a Moore extruder, and it had I think it was a 1.2mm nozzle, which was pretty badass, and so that's sort of why it was justified to have a 3mm filament. But then I realized, I'm like, well, if it's only 1.2mm filament, then the 1.2mm nozzle, the 1.75 filament should be plenty to feed that, right? And anyway, so I do have some leftover spools of 3mm filament. If anybody else is hard up for some 3mm filament, I'll definitely sell you at a greatly negatively discounted price. And I'll sell it to you for more than I paid for it. Now, actually, probably have it, because I'm never going to use that Taz 6 ever again unless they need to torture me for some reason, and then I will try to fix it and then try to use it. That thing was so unreliable in so many ways. It was cool when it worked right, and where I was going with that was with the polycarbonate on that. That actually had a borosilicate glass bed with a PEI coating, which was actually a really good bed, other than it was really expensive, and I broke multiple ones, and that really got annoyingly expensive. And when I say expensive, I mean the stock one the original one had the heater built right into it. That was like $150 print bed, so that was annoying. A couple times I broke that. But then you could get a two-piece one which had a separate heater from the glass, but that one, oh, my battery's almost dead. Let me plug in here. Hopefully we can not die. Don't die. Just happen to have a charger cable there. All right, we're charging 5%. Hopefully we don't. So if I rudely, abruptly stop, probably just because my battery died, or who knows what. But anyway, yeah. So that one nice thing I did like about that Taz was that glass bed was excellent for printing the polycarbonate, because I didn't worry about warping issues on the polycarbonate other than if it cracked. And I actually printed this big plastic hook out of polycarbonate on that once, like the letter, sort of a capital J without the T part, and it really was awesome. And I used it as a bike hanging hook. Like I was hanging with my e-bike off of that hook, and that e-bike was like 75 pounds, and that hook was plenty strong. So that was kind of cool. But you know what, come to think of it, if those two little hooks are hanging my 45-pound barbell, then I could have just made a bigger PLA hook that probably would have held it. But on the other hand, I'm working on the bike, and if it broke and landed on my toe, I would be irate. So, update on the print. Still printing nicely. So to reiterate, to get rid of the wrinkling, increase the bed temperature significantly from, I think, 45 to 75, as you can see here. I moved fast. I don't want you to see the junk in the trunk under the print bed. There's my temperatures. And in order to, so I think my problem with the failure on the last couple prints was the softening of the filament due to heat creep in the cold, into the cold end, causing a jam, and so have decreased the filament temperature, the nozzle temperature, to 200 from the standard 230. Now these temperature changes are only on the initial layers, not on all the layers. So once it finishes the first or second layer, I'm not sure which, then the temperatures will go back up to 230 and down to 45, I believe it is. And so, but at that point, hopefully it'll work. Now, the funny thing is, I did make some, one thing I noticed, actually, now that I think about it, one thing I did notice that is a little bit problematic with the silk PLA is, for years I've been making my own custom supports in tricky to support areas. And so I did that on, there's hooks on this shelf, right? So it's a shelf, it's printing upside down, it's got hooks underneath. And so the hooks, it's like printing an upside down capital J, it needs supports. And I don't like the way the custom support, the standard supports were supporting it. And so I decided to make my own custom supports. And so I did that. And what I typically do when I make my own supports is I in the CAD, is I put a 20 thousandths gap in between the part and the support at the top and at the bottom. And I find that generally with PLA, regular PLA anyway, that tends to print well, and then it's also fairly easy to remove very consistently. And the nice thing about doing that is I can follow the contours very closely to any curvatures and have them come out really nice, because it's not just like a zigzag of lines under it and then sort of sagging between. I'm making the full curvature. I'm supporting the full curvature like 20 thousandths of an inch under it, half a millimeter. But what I'm noticing with just finally with this print, or with the test coupons for this print, was that with the silk PLA, or at least with this silk PLA, that 20 thousandths was not bonding well enough to act as a support, because the supports were just falling off. So I actually, let me think about that. Now I'm gonna correct myself as I think this through. How did that play out? Because I changed it to like 15 thousandths. Oh, I know what I did. So I changed it to like 15 thousandths, and it was still unreliable. But then what I did, now I remember what I did. Oh, and I hope I did it on the final print. I think I did. As I basically put little, like 1/2 millimeter diameter, a couple cylindrical pegs right through all these supports, just to sort of solidify them just enough so they don't fall off each other. And what I mean by that, I don't know if I have a piece here to show, is the test piece So what I could do is just do a solid, I don't see one here. In theory, I could just do a solid custom support from under the hook to the surface that the support is sitting on. The problem with that is it can be tricky to get out if it's sandwiched between two features of the final print. And so what I tend to do is sort of put like a split line, and so it's two pieces of the support. But I was having a hard time getting some of the supports off, and so what I decided to do is I split it I split the support. Instead of being a solid piece or a two-piece piece, I split it like 4 lines, so it's like a 5-part support, so it can kind of crumble apart much more easily. And so I put these joining sort of, toothpick size joining rods through this filament. So theoretically they'll hold together for the print, but then I should be able to break them off easily enough when I go to take them out. We'll see how that plays out. I think